NAIT Center for Boreal Research. The Hummock Transfer Technique for Temporary Access Features Reclamation in Boreal Peatland. Exploration of resources in Alberta creates numerous temporary access features such as seismic lines, winter roads, and exploration wells in boreal peatlands. In this video, we will showcase a new technique to reclaim and restore temporary access features built in these wetland ecosystems called the Hummock Transfer Technique. Peatlands cover large areas of Alberta's boreal region. They provide habitat for wildlife, regulate floodwater, filter pollutants, and store large amount of carbon as peat. Most of Alberta's peatlands have a ground layer dominated by mosses, which are also the main contributors of peat accumulation. Although peatlands may appear relatively flat compared to upland forests, there are small variations of the ground surface usually referred to as microtopography by ecologists. An individual hummock is easily distinguishable by its dome shape and elevated surface, and is usually dominated by mosses and highly adapted shrubs and small trees. Low hollows vary from very wet and dominated by herbs to very dry and dominated by lichens. Although construction is usually completed in winter under frozen ground conditions, the clearing of vegetation and repeated access of temporary access features often lead to flattened surface topography, altered moisture regime, and shift in species composition compared to undisturbed peatlands. These changes can compromise critical functions and services such as wildlife habitat and long-term carbon sinks provided by natural peatland. Without active reclamation, many of these features will remain open with little woody vegetation and limited peat accumulation potential. The key goal of reclamation of these features is to introduce microsites and topographic features on flattened temporary access features to increase structural and floral diversity, particularly woody vegetation and peat-forming mosses, which in turn will promote the return of functions and services offered by natural peatlands. Current practice to reclaim temporary features usually involves mounding of compacted soil surface where the living ground vegetation such as herbs and mosses are inverted and buried, followed by planting of stock tree seedlings on exposed and highly decomposed peat. Here, we present a new alternative option called the Hummock Transfer Technique. In this method, intact hummocks including mosses, herbs, shrubs, and small trees from nearby natural areas are collected and placed directly on the flattened temporary access features without inverting the soil profile or flipping the hummocks. In this video, we will demonstrate how the Hummock Transfer Technique was applied at several seismic lines and winter roads on a pattern fen and bog complex near Drayton Valley, Alberta in March 2019. The equipment you'll need is a low ground disturbance tracked excavator with a digging bucket equipped with frost teeth. Winter frozen condition is preferred for equipment access and to minimize additional disturbance during operation. Situate the equipment at the far end of the line and work backwards to avoid compaction of transferred plants. Target tall, mossy hummocks with trees and shrubs. By working in frozen conditions and close to the frozen layer, we can avoid severe damage to dormant roots and rhizomes. Gaps between the frost teeth on the bucket will leave behind chunks of living mosses along with seed and spores that can regenerate. Stock seedlings can be planted on top of the hummocks if needed, as done in this research trial. Maintaining the structure and orientation of transferred hummock throughout the collection and transfer is critical to the success of regeneration. By targeting mossy hummocks with trees, shrubs, and herbs, all structural and floral components desirable for recovery are introduced in one step. Mosses can help maintain the structural integrity of the mounds while regulating moisture internally through capillary action, which in turn will help vascular plants survive and grow. Bend-down trees with seed cones can supplement tree regeneration on the hummocks. Overall, the Hummock Transfer Technique was very successful in this field trial and showed great potential as an effective approach to introduce microsites, enhance woody establishment, and accelerate peat accumulation function recovery on temporary access features in peatland. This project is supported by Environment Damage Fund and NCERT, and carried out in partnership with University of Waterloo, Mount Royal University, and Choice Environmental Consulting Group. To find out more, visit www.nait.ca/boreal research or refer to technical note number 30.